We're going to do the next column. This is revised seasonal factor. If we take the total of the 12 months, then we should get a total of 12, but it won't be. Equals sum of, you want to make sure you get 1 year. So if it was quarterly, it would be 4. Notice it's slightly above 12. Error. This equals that minus 12. Or you could do 12 minus that. Per month, that just equals the error divided by 12. If you were doing quarterly data, you divide by 4. Revised seasonal factor. Now you could, if you wanted to, skip the error one and just do a calculation out for here per month if you wanted to. Since on average the ASI is that much 0.000575 too much, the revised seasonal factor will equal the average seasonal indicator minus that amount. If you had done it as 12 minus, that would be negative and you would add. Take this, copy it down. Whoops, Control Z. Forgot to make the E5 a fixed reference. Now copy and paste that down. Let's check to make sure we've done it correctly. Copy this over. The sum is now 12. Exactly what we wanted. Here we could copy that formula down, or we could do like we did before, equals 1 year before. Copy that formula down. And then total seasonal factor. Total seasonal factor equals that divided by 12. Copy that down. What do these numbers tell us? Well, total seasonal factor here tells us that typical July we do just under 7% of our sales for the year. In August it's about 10%. Continue down, December's about 18%. Then you get February about 2%. One thing you'll want to do is just verify that your numbers make sense. Copy this over, get 1. So that part makes sense. And if we go down to the bottom, April is a 0.0407. Go up to the top, we should get the same value for April, 0.0407. So the total seasonal factor is telling us what percentage of our sales are done in that month. The revised seasonal factor is done by, the revised seasonal factor helps us to adjust for seasonality. Our adjusted values equals our actual value divided by the revised seasonal factor. So like in July we do less than we would normally expect if the sales were evenly spread out, so we got to increase it. December, going to decrease it because we want to adjust for seasonality. And we copy this formula down. note that the December sales, 246, went down. That's because we expect abnormally high sales in December, so we seasonally adjust down, where July went up. We expect abnormally low sales in July, so it goes up. If you were to seasonally adjust all, what you would need to do is you need to extend the total seasonal factor up and down. So like this is going to equal the June that's after it. Copy that formula up. Actually, we need to do that with the revised seasonal factor. That equals the June below. Copy that formula up. And then the May equals the May above. Copy that formula down. And then we can copy this formula down. Copy this formula up. I'm not sure why it added in an extra row here. That is correct there. We could copy that down if we wanted to. Now, if we were to, so here's seasonally adjusted. If I gave you one bit of data, you would just do it the exact same way once you knew the revised seasonal factor. If you wanted to find out your sales in a particular month projected, let's suppose your annual sales is 1,000. Then in July of that year, it's going to equal that times the total seasonal factor for July, which is there. It gives us 69.55.